Section 2.6, Piecewise and Absolute Value Functions. This is part 1. We're not going to talk about absolute value functions today. We're just going to talk about piecewise. Piecewise is graphs that are in pieces. A line does not go on forever and ever. They're going to stop. They're going to be pieces of the line. That's why it's called piecewise. In this example, the equation and graph of the function f of x are given. Determine the function values at the specified domain values, and then determine the domain and range of the function. F of negative 3. Here are 3 equations right here. This is the same thing. The first one, f of x equals x plus 4. That is the same thing as saying y equals x plus 4. And the second equation, f of x is equal to 5, that's the same thing as saying y equals 5. And the third equation, f of x equals 13 minus 2x, that's the same thing as saying y equals negative 2x plus 13, if you want to put it in slope-intercept form. Example A, f of negative 3. Which function are we going to use? Well, these are over here are the restrictions. So we have to see, where is negative 3 true? Look at the first equation. Is negative 3 less than negative 2? Yes, it is. So we are going to use this function. So we see x, we're going to plug in negative 3. And when you plug in negative 3 plus 4, we get 1. So that is like the ordered pair negative 3, 1. If we plot that point over on the side graph, negative 3, 1 is right here. Which is this line, which corresponds to this equation. F of 1, where is f of 1 true? Well, let's look at this first equation. If we plugged in 1, is 1 less than negative 2? No. So that doesn't work. Is 1 between negative 1 and 3? By the way, negative 2 is less than x is less than 3. Another way of saying that is x is between negative 2 and 3. And yes, 1 is between negative 2 and 3. So we are going to plug in 1 into this equation. Well, x is 1, y is always 5. So that's the ordered pair 1, 5. And this equation, y equals 5, is a horizontal line at 5, which is this graph right here. Plot the point 1, 5, and it lands right here on that line. The second equation, the third equation, f of 7, which restriction is it true for? The first one, is 7 less than negative 2? No. Is 7 in between negative 2 and 3? No. Is 7 greater than 3? Yes. So we're going to plug in 7 right here where we see x. So that's 13 minus 2 times 7. 13 minus 14 is a negative 1. So we're going to put a negative 1 right here. That is the ordered pair 7, negative 1. Plot that point, 7, negative 1, and it lands on the third equation, the third graph, which corresponds with this equation. Now, I want you to try to do the last 3. So pause the video and try to do these last 3 on your own. F of 3, that is true for the second equation, and anytime you have the second equation, the graph is 5. So that's the ordered pair 3, 5. So if you plot that point, you will land on the second line, which is right here. F of negative 2, that is true for the first equation because negative 2 is less than or equal to negative 2. So we're going to plug in negative 2 in the first equation. Negative 2 plus 4 is 2, which would land on the first graph. So we could plot the point -2, 2. We land right there. And f of -12 is true for the the first graph. -12 is less than or equal to -2. So -12 plus 4 is -8. Now we need to calculate the domain and range from all of these graphs. The domain, we want to look at the x's. So this graph keeps going on and on and on and on. So from the negative direction, it starts from -infinity, and then it keeps going. It stops here, but it picks up on this graph, and then it stops here, but it picks up on this graph with the arrow going on and on and on. So it goes from -infinity to +infinity. And the range values, which is the y, we have to look going down from down all the way up, and this line keeps going on and on and on down, so it goes from -infinity, and it stops right here at 7. And there is an open circle at 7, so we have a parentheses. Number 2, a g of 0, which restriction is this true for? Is 0 less than -3? No. Is 0 between -3 and 2? Yes, it is. By the way we would read the second restriction, we don't read it -3 is less than or equal to x is less than 2. We read this as x is between -3 and 2. And 0 is between -3 and 2, so it goes true here. This is a little blurry to see. 0 times that's 0.5x is 0, and 3 minus 0 is, that should be is 3. Example B, g of 3, which one is this true for? That is true for the second equation, the third. 3 is greater than or equal to 2, so the equation is -3. G of -4, that is true for the first equation. So we're going to plug in -4 into the first equation. That reads -4 minus 2x. So that's -4 minus 2 times a -4. So that's -4 plus 8, which is a +4. G of 2, where is this true? This is true in the third one. It's not true in the second one because it says x is less than 2. It's true for the third one because it says x is greater than or equal to 2. So that would be a -2. G of -8, that is true for the first one. So that reads -4 minus 2 times -8. So that's -4 plus 16, which is 12. And g of 7, that's true for the third one, so that's a -7. Now to calculate the domain and range, so we have to look at our graphs. Domain goes from left to right on the x-axis. So this arrow says it keeps going on and on and on, so the domain is -infinity to, and this arrow goes on and on and on, so it's to +infinity. The range is from bottom all the way up. So starting at the bottom, because this arrow on this graph keeps going on and on and on, it's -infinity and go up. What I would like to do is I like to kind of slide my pencil upwards. It stops right here at -2. And do you see this gap right here? There are no graphs. So it stops at -2. And it's a closed circle, so we put a bracket, union with, and it picks back up at positive 2. And it's an open circle at positive 2, so we use a parentheses. 2, and then it just keeps on going, going, going because of that arrow. Okay, number 3 is practicing looking at the graphs and determining the domain and range. So, the domain, because of this arrow, it keeps going on and on and on. So, the domain is negative infinity to, it stops right here at the 6. And the 6 is included because it's a closed circle, so we have a bracket. Now, the range is the y, so it does not start until right here at negative 4. And negative 4 is included, so it's negative 4 to, because of this arrow, it's going up and up and up and up, so it's to positive infinity. And anytime you have an infinity, it's always a parentheses at the infinity. The second one, it's on our x-axis. It starts right here at negative 6. Or excuse me, that's negative 8. It's a little on the blurry side. And it stops right here at the 6. And they're both open circles, so we'll use parentheses. Now the range, it starts at negative 6 and goes up until you get to negative 2, and then it stops. So there's a gap right here. And it's an open circle, union with, and then I'm sorry, not at negative 2. That's at negative 1. Right here, we go on our y-axis. We're looking at our y-axis, so that's negative 1. And union with, and it picks it back up right here at positive 1. And again, it's an open circle, so we use a parentheses. And it stops right here at 2 with this graph, but it picks it back up with an open circle. So we can just continue on all the way to 7. And it's a closed circle, so we use a bracket. The third graph, we're looking at our x-axis, and it starts at negative 7. And because of it keeps going, 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 and because of this arrow, it goes to infinity. Now our range, now be careful about this one. It starts at negative 8. It stops at negative 2 with a bracket because it's a closed circle. And then it picks back up at 1, but it's an open circle at 1, so we're going to have a parentheses. And it stops at 4. Now look right here. It stops at 4 and it picks back up at 4. But if you notice, there's an open circle at 4, so 4 is not included. So everything but 4. So it stops at 4 with a parentheses, union with, and it picks back up at 4. And then it stops, that is at 8 right here. And 8 is included, so we use a bracket. We have two functions, f of x equals x minus 2, and f of x is equal to x plus 3. So what I would do, let's graph the first equation. That is the same thing as saying y equals x minus 2, where your slope is negative 1, 1 over 1. Your y-intercept is negative 2, which is the 0, negative 2. So I'm going to plot 0, negative 2. I'm going to go up 1 over 1, up 1 over 1. I can also go down and backwards because to go in the opposite direction, that's negative 1 over negative 1. Okay, so notice I graphed the entire equation. Now look at this restriction. X is less than -1. So that means, look at, that's kind of like your boundary point. Where is -1? Right here. What's to the left of -1? This graph over here is to the left. So everything to the right of it we need to erase. And I kind of erase that, but it's a less than -1, so it's an open circle at -1. The second equation is x plus 3, so your slope is 1/1, your b is 3, which is the ordered pair 0, 3. So I'm going to graph that and make several points. Now the boundary is x is greater than or equal to -1. So here's my boundary right here. And it's greater than, which is to the right. So my line is only going to go to the right of this. So everything, all these points to the left, I'm going to erase. Now, is it an open or closed circle at -1? It is a closed circle because it's greater than or equal to. So there's the graph. Now we're going to graph f of x equals x plus 2 and f of x is equal to x. So the first one, the slope is 1/1, your y-intercept is 0, 2. Okay, there's my dots, but before I draw my line, I'm going to look at my restriction. My restriction is x is less than 0. That points to the left of 0, which start right here. So everything to the right, the points I'm going to erase. So my boundary line is 0, which is the same thing as my y-axis. And then f of x is equal to x. That's the same thing as saying y equals x plus 0. So your ordered pair is 0, 0. Starts at the origin. You go up 1/1, up 1/1, or to the left and backwards. Now the restriction is x is greater than or equal to 0. So that's to the right of 0. So it's all the points to the right, which is right here. And I am going to erase the points. Now, right here on this second equation, I should have had an open circle. And the second equation, because it's a greater than or equal to, I'm going to have a closed circle. Let's state the domain and range on this equation. The domain is all real numbers, so it's -infinity to +infinity. And the range is also -infinity to +infinity. Okay, this has three equations. F of x equals 6, that's the same thing as saying y equals 6, which is a horizontal line at 6. Now the restriction is x is less than -4. So here's -4. So it's to the left. So I have to erase this line. and it will be an open circle at -4. The second equation, y equals 2x plus 3. Your slope is 2 over 1. Your y-intercept is 0, 3. Now I'm going to look at the restriction. The restriction, this says right here, -4 is less than x less than 1. That is saying x is between -4 and 1. So here's my boundary at -4, and here's my boundary at 1. So the graph is in between that. So here's 0, 3, so I'm going to go up 2 over 1. But I'm going to stop because I can't go to the right of the 1. And I'm going to go the other direction, down 2 to the backwards 1, down 2 to the backwards 1, down 2, backwards 1, down 2, backwards 1. I am going to have an open circle at -4. No, I'm sorry, it's a less than or equal to, so it will be a closed circle, and it'll be an open circle at 1 right here. So now I'm going to connect my line, everything in between. The third equation is y equals -3. That is a horizontal line at -3. And the restriction is x is greater than or equal to 1. So I know it's got to go to the right of 1. So when I go to draw my line, I'm going to start at -1. And I'm going to go to the right. And it will be a closed circle at -1. The last equation, g of x is equal to x. That is the equation y equals x, x plus 0, 1x plus 0, which is the origin. And we're going to go up 1 and over 1. But look at the restriction. X is equal to, the restriction is -5. So I'm going to go ahead and make my border. Now, I need to start at 0 right here. And I'm going to go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. But my line, I'm only going to start right here. So all these points I can erase. And it will be a closed circle because it's less than or equal to. The second equation is y equals 2x plus 3. So that's the order pair 0, 3. I'm going to go up 2 over 1. But now I'm going to go ahead and look at my restriction. It's between -5 and 2. So there's my border. -5 is already. So the line is going to go in between them. So when I'm doing my rise over run, I'm going to keep it in between those two borders. So right here at -2, it's going to be an open circle because 2 is not included. And then I'm going to go down to the right 1, down to the right 1, down to the right 1. And this will be a closed circle. And draw my line. My arrow will be closed circle. Because -5 is included. The very last one, that's y equals -3, which is the horizontal line at -3, and it's between 2 and 6. So here's one border 6, 2. And here's the other border 6. And it's a horizontal line at -3. And there's both included, so it'll be a closed circle at both of them.